Oh, success. Okay. And so that's what we were doing. Now, that will be one question on this next test. And the next test, I think, I'm looking at next Wednesday. I think I was looking at Tuesday, but then I decided I'm going to take off this Friday. So, again, Friday, no problems, I take it, right? Because I didn't hear from Mr. Flanagan. So I think we're going to do the exact same thing again. You're probably going to be with Mr. Flanagan again. Is that a good arrangement?
Yeah.
Okay, and so what I'll do is I'll change my assignment I gave him that said 3-3, and I'm going to change it to 3-10 and hand him the same thing. And he's probably going to be okay with that, okay? So we'll take off Friday, so that pushes us a day back. So again, I think I'm looking at the next exam being, or quiz being next Wednesday. Okay, and so what we have on that are these puzzles, which we just talked about here a second ago. 1, 3, 6, 7. Oh, what's up, Peter? So we have those puzzles. The second thing we're going to have is what we're going to talk about today. Well, what are you doing? We're going to do the things that we talked about today. And the things we're going to talk about today is writing these equations that we're going to write. Now, I'm just going to tell you right now, with these equations that we're going to write today, I guarantee you, this is the thing that people will miss the most points on the next test, the next Wednesday. Okay? And it's because you've got to follow a set of simple rules, and you got a little memorization to do. So I'm just saying that what we're doing today looks like it's pretty easy. Practice, okay? Do the homework and you'll make your mistakes now, because you will make mistakes with this, right? So, here we go. So this is, we're going to talk about standard enthalpy, yeah. Congratulations, too. Any other basketball players in here? Adam, yeah. Is that a pretty exciting finish?
Oh yeah.
Yeah, somebody was watching the Twitter feed because we were wrestling at the same time. I was hearing it. So I knew that you were what? Up by 1 or down by 1 with like 19 seconds left or something like that. That was the last I heard, and then I heard you won. So what happened in the last 20 seconds? You just keep the lead?
Well, they came down and they banked a 3 in actually. So, and then we came down. Jared scored late with about 10 seconds left. They come down, they throw up a shot, it goes out, they tip it out. So they have like an inbound play. They throw it out, he shoots it, and the air balls it.
Nice.
So,
And so what's next now?
we play Central Mountain, who's actually, I think, not as good as the team we play.
Okay. And when's that?
Friday.
Good. Okay, so standard enthalpies of formation. Okay. All right, so standard enthalpies of formation. Well, let's just do it first, and then we'll get to that stuff later, I guess. This is the change in enthalpy associated with. So again, when I say change in enthalpy, what are you supposed to be thinking? Heat, right? Under the things that we're talking about, enthalpy changes are essentially heat. So change in enthalpy associated with, or the heat associated with, change in enthalpy associated with the formation of now here's the first key, 1 mole of a compound. So the first thing is, when you write these equations, you always got to have 1 mole of product. You are forming 1 mole. So what that means is on the product side, it's always going to be coefficient 1 or no coefficient. That means on the reactant side, you can get some screwy looking coefficients. You can get fractions. You can get whole numbers. You can get fractions. Because again, you have to keep the product at 1 mole. You'll see this when we do examples. So it's the enthalpy associated formation of 1 mole of a compound from its elements in their standard states. And so that's something important there too, standard states. and their standard states. Okay, so what's the standard states? Okay, standard states, that's where we're next. Standard states. So standard states basically are, how do these elements exist naturally under normal conditions? Okay. Well, first of all, the color tells us something. What's the color of the symbol tell us?
State of matter.
State of matter. Okay. So the state of matter. So the vast majority of these will be what state of matter? Solid. But these guys over here will be what? Gases, and a couple of these will be liquid, not many, right? Okay. Now the other thing I want you to remember is you should know something about H, N, O, F, and Cl. What should you know about them? In particular, say O or H. How do they exist?
Gases.
They're gases, yes. What is it, Ronnie? Two. So it's H2, N2, O2, F2, Cl2. Follow me? Okay. The rest of these, like if you were in calcium, it would just be calcium solvent. Or if it was beryllium, it would just be beryllium solvent. There are some other ones that I won't make you memorize. Like a standard state, a normal state for phosphorus is P4. I'm not going to make you memorize that one. So there's some of these I won't make you memorize, okay? Sulfur, a natural state for sulfur is S8. So I don't want to get over doing the memorization thing, but let's just get through some of this, okay? So say for a compound, let's say, okay, so we'd say for a gaseous substance, come on, man, why are you doing this to me? For a gaseous substance at 1 atm. Now, to be quite honest, we're not really going to come across that too much, but I'm still going to give you these rules. So let's say we have a compound, say it's CO2, okay, and it's a gas. Well, I would say, what's its state at a pressure of 1 atmosphere? It'd be gas. You know, if I take CO2 and I take it up to hundreds and hundreds of atmospheres of pressure, well, then I can probably make it a liquid at some point, or I can make it a solvent if I apply enough pressure. So we're just talking at normal pressures. And again, we're probably not going to come across this one too much either, but I'm still going to say it. For a substance in solution, it would be 1 molar. That would be its concentration. But again, we're not going to come across that much. What we're going to come across are these element ones for an element. We will come across the other two, but just not that much. So this is going to be as it exists at 1 atm and 25 degrees C. So for all practical purposes, not exactly, that's the conditions that we have up here. And why I say practically the same is this is at 273 K and 1 atm. So this is at 0 Celsius, not 25. Okay? So that could mess up maybe one element someplace in there, but not really. I don't know if there are any that are, because the one that I'm really aware of is gallium. And gallium's melting point is 302.92, so 303. Well, that's 298. So we still haven't gotten up to the temperature where this thing would melt. Follow me? So basically all the elements, the state that they are on the periodic table does match that set of conditions right there for all practical purposes. And then, so for example, we'll say sodium would be a solid. And Calcium would be a solvent. Here's one I do want you to know in addition to some of those other ones. Bromine is bromine 2 with a liquid. So that's one other one I do want you to memorize. And it just froze here. There it goes. And we have others like, say, H2 gas or O2 gas. All right, so the first challenge in writing these equations is knowing your standard states. So all I got to say is you got to learn your standard states. It's not that hard, all right? Basically, you've got a handful of ones that you got to know have a subscript. H2, O2, N2, F2, Cl2. And they're all gases. And then you have Br, which is Br2 liquid. And then the rest of them are basically single elements, and their state is whatever their state says up there. Solid, liquid, or gas. So let's do some of these equations now. And again, that's the first thing. The second thing is you got to write this for 1 mole of compound. So let's do write the reaction for the enthalpy of formation. Write the reaction for the enthalpy of formation for NH3 gas. It's freezing up. Just a second. All right, yeah, that sounds about right. Okay. Oh, look at that. That was interesting. Okay, so I guess I'm going to try and show this differently this year. Okay. Yeah, I think I'm going to show this differently this year because maybe this will help. So maybe in the first step, what I'm going to do, I'll do this stepwise now. Of course.
Mr. Martin,
Yeah.
what's the word after form?
Formation for NH3.
No,
The
one about.
write the reaction for the enthalpy of
Okay, gotcha.
formation. Okay. So is it the?
Mhm.
Okay, let me fix that. You can't read it. Probably somebody else can read it. Okay. I don't know that that was any better. Okay. So the first step we're going to do is we're going to write down the thing that we're trying to form as 1 mole of product. So you see we're forming that? Okay. So now we've satisfied the one thing. We're forming 1 mole of this from the elements in their standard states. So this is NH3 gas. Okay. So what would the standard state of N be?
N2 gaseous.
N2 gas. And what would the standard state for H be?
H2 gas.
H2 gas. Okay, so now I've formed it from their elements and their standard states. Now I got to balance this thing. And when I balance this, I can't go messing with the product. The product has to stay 1 mole. So what would be the coefficient I'd have to put in front of N2 to get that to balance? Andy?
Half.
Half, yep. So it's going to be 1/2 N2 gas plus, what about for H? 3 halves. Okay. 3 halves H2 gas. So now that's balanced. Okay. So it looks goofy, but remember, that's got to stay 1. These got to be standard states. So I can't just say H because I can't just say N because it's easier. You know, N is not floating around the atmosphere as N, it's floating around as N2. Okay. So that's an enthalpy of formation. Let's do another example. let's say for C3H8 gas. So again,
Wait, but wouldn't
Yep.
that reaction also not tend to occur naturally?
It could- it
Since,
could.
Half of the
it may or may not. Let me just put it that way. You're going to find out later. What we're going to do is we're going to have, in the back of our book, we have pages of tables. And those tables tell us how much energy is associated with that very reaction. So I go back and I look up in the table and it says NH3 gas, and there's a delta H associated with it. And that delta H is describing that reaction right there. Okay? Now that reaction might be endothermic or exothermic. So it may or may not occur spontaneously. All right, so for this, let's say we have this stuff, C3H8. This is propane. Okay. So it forms from the elements in their standard states. Okay, so let's see. What would the standard state for carbon be? Anybody?
C solid.
C solid. Plus, what do we say hydrogen standard state is? Everybody? H2 gas. And so then I'm going to go put in coefficients here as needed. C3H8 gas. So coefficient in front of carbon. It's what? 3, right? So there it comes out a whole number. And what about for H2? 4. Okay, so that's balanced. So again, you know, I'll tell you, the things that I see, the mistakes I see is people not making that 1 mole. Okay? The other mistakes I see is people not knowing their standard states. If you know both of those things, these are not that hard. Okay, now that's a standard enthalpy for formation. Let's do this. Write the equation. For the enthalpy of combustion for C3H8 gas. Or no, I wanted to do this. Oh, okay, sorry about this. Let me fix something here. My notes are wrong. So let's do this for C4H10 liquid. Fix that. Okay, so now this is a little different because this is now an enthalpy of combustion, not formation. So if you're forming something, it's a product. What's combusting mean? What are you doing?
Burning.
I'm sorry, burning it, right? What do you have to burn something? It has to combine with oxygen to form. What do you get when you burn something?
CO2.
And?
Heat.
Okay. CO2 and? What happens when you burn something? Well, when you burn gasoline in your car, you get CO2 going out the tailpipe, right? Why does your tailpipe or exhaust system eventually rust out?
Water.
Water's also coming out of the reaction too. Okay. So when I do this equation, I got to keep the C4H10 at 1 mole. So if this is combustion, this is going to be C4H10 liquid plus O2 gas, because that's its standard state, forming CO2 gas plus H2O gas. And it would be gas because if you're burning something, it's going to be hot, and that's going to make the gas come off. Okay, so now when I go balance this thing, I'm not going to mess with the C4H10. I'm just going to leave that in terms of 1 mole. So I'm going to rewrite everything, and I'm going to go balance. Gas yields CO2 gas plus H2O gas. All right, so if I'm going to go balance, I'd probably go balance my carbon first. That would give me 4 carbons there. And we've been through this before, so I'm not going to break this down into steps. But next I should probably balance up H's, because they only appear in 1 compound on each side, so that would be a 5. Then when I go balance O's, I have 8 O's from CO2, and I have 5 more O's from H2O. So that's a total of 13 O's. So I'm going to make this 13 halves, and I'm going to stop. I'm not going to try and get rid of that fraction because this needs to be in terms of 1 mole of the thing that you're talking about. And again, I can go look up on tables and find out what that enthalpy of combustion is. I can say if I burn 1 mole of C4H10, how much energy would be associated with it, and boom, I can look that up because it's a state function. Right? It's specific to that substance. That's how we know how far you're going to go when you put gasoline in your car. You know what I'm saying? You get so many miles per gallon. Well, why do you? Because it's reliable the amount of energy that's in that gasoline. And let's just do one more for good measure here. Let's do write an equation for the enthalpy of solution for CaCl2 solid. So what this is basically just like dissociation equations, which we wrote already this year. Remember you did a lab where we measured the conductivity of solutions? You took drops of salt liquids and you put them into water and you watched the conductivity go up and up and up. That was because when you put the solid into solution, the particles split apart because they got ganged up on water. Remember, you got hydration spheres. And those hydration spheres now have charges that can carry a charge through the solution. Okay. So if I take CaCl2 in the solid form and I put this into water, I get 2 things. I get Ca plus 2s and I get Cl minuses. Both of these are aqueous. And I have 2 Cl's and 1 Ca. And again, keep the thing that you're talking about at 1 mole. We're talking about CaCl2. Okay, easy enough? Okay, so let's look at a homework problem.